Hello, and thank you for joining me for another Baddies in Tech TryHackMe Night. We are going to go over the IDOR room on the TryHackMe platform. And let's see here. This is part of our, I think this is a junior penetration tester path. Let's go to the dashboard. View path. Yes, this is our junior penetration tester path that we're working on here. We went through introduction to cybersecurity. We've gone through pen testing, where we looked at some pen testing fundamentals, some security stuff. And we are now on the introduction to web hacking. Um, and so today we're focusing on IDOR. And IDOR stands for Insecure Direct Object Reference. It is a web vulnerability that occurs like essentially when an application uses user supplied information to directly access objects without the proper like checks and controls and stuff like that. And it allows attackers to bypass authorization. Remember our AAA here, and access resources they shouldn't have access to, like data, files, anything, right? So essentially, the way IDOR works is that um, you have an application that relies on user input. So, for example, you know how sometimes you'll be shopping. Let's pretend like TryHackMe is a shopping website, and it'll be something like customer um, ID equals 12, and that would be mine. And yours is customer ID 13. But if you put in number 12 into your browser, you'll be able to find and get my information. And that's what the attacker would do. The attacker would go in and say, well, I'm number 12, or I'm number 13. Who's number 12? And they would go in and put in number 12, and they would have like my address, my name, my credit card information. And also it can be like that is very important information, and that's the unauthorized access of the data. There are some preventative measures that you can use to ensure that IDOR is like your application is not vulnerable, like of course validating user input, like avoiding using direct object references in your URLs, access controls, and testing. Of course, testing is very, very important in the environment. All right, so let's go ahead and get started in our Try Hack Me here. I see this little button saying start attack box. Let's not forget that button exists. Okay, so what is IDOR? In this room, you're going to learn what an IDOR vulnerability is, what that looks like, and how to find them, and a practical task exploiting a real case scenario. IDOR stands for Insecure Direct Object Reference, and is a type of access control vulnerability. This type of vulnerability can occur when a web server receives user supply input to retrieve objects, files, data, documents. Too much trust has been placed on the input data. It is not validated on the server side to confirm the requested object belongs to the user requesting it. That's kind of like our AAA all wrapped in one right there. What does IDOR stand for? Insecure Direct Object Reference. Let's go ahead and put that in our box. Perfect. Got it. Cute. We got a little badge. An IDOR example. Imagine you've just signed up for an online service and you want to change your profile information. The link you the link you click on goes to HTTP online service TryHackMe user profile. Profile user ID equals 1305, and you can see your information. Curiosity gets the best of get gets the better of you. Curiosity gets the better of you. And you try changing your user underscore ID value to 1000 instead. And to your surprise, you can now see another user's information. You've now discovered an IDOR vulnerability. Ideally, there should be a check in a website to confirm that the user information belongs to the user logged requesting it. I feel like I'm like skipping over words and I'm not sure. Using what you've learned above, using what you've learned. I forgot this is like a different uh these folks are like overseas somewhere. That's why. That explains a lot. Using what you've learned above, click the View Site button and try to receive a flag by discovering and exploiting an IDOR vulnerability. What is the flag from the IDOR example website? So let's go ahead and open our website. Check through the emails below and try and identify an URL that looks like it could potentially be vulnerable to an IDOR application and click on it. Okay, so we have shipping. This is from shipping. So I guess we purchased something. Your order number is 1234 and it's saying go here. Okay, that's interesting. Thanks for your recent online order. This is from orders at onlinestore.tryhackme. You can review your invoice by clicking. Oh, that looks good. I like the way this looks. No reply. Take a look around and join rooms to enhance your security skills. Join our Discord and be part of the community. For details about connecting to our network, go to your access page. Okay. And Joe, hey, just wondering if you're still playing poker with us this weekend. Let me know. All right, so I see something here. This looks really good. Okay, so order number 1234. Let's see if we can we are we supposed to like put five in here? Oh, it tells me right above. Read your screen, folks. Now you can view your order confirmation, which contains your details. Try changing the URL below to view the order number 1000 and press enter to load the new URL. All right, there we go. Try Hack Me IDOR. This is for Reese Saunders. And who was I? I forgot who I was. You know what? That's fine. We're Reese Saunders. I think my name was, I completely forgot. Okay, perfect. I think we're done with this. So we'll go ahead and close that little window. So the text is nice and large for glasses wearing folks. Finding IDORs in encoded IDs. When passing data from page to page, either by post data, query strings, or cookies, web developers will often first take the raw data and encode it. Encoding ensures that the receiving web server will be able to understand the contents. Encoding changes binary data into ASCII strings, commonly using the lowercase a to z, uppercase a to z, 0 through 9, and equal sign characters for padding. The most common encoding technique on the web is base64 encoding and can usually be pretty easy to spot. You can use websites like base64decode.org to decode the string, then edit the data and re encode it using base64encode.org, and then resubmit the web request to see if there's a change in the response. See the image below as a graphical example of this process. So we have our graphic here, and it's a really good little graphic because it shows that we have our string here that and we applied the decode to it, and we see that this string right here returns that ID 30. So we modify that. We modify ID 30 to ID 10. And then we re-encode this ID 10 and we get this change right here. Like the T, the letter T. It went from what, M to T? No, Z to T, uppercase T. And then we take this new encoded message and we put it into whatever, our web browser, or if we're using some kind of tool, and we submit it to the website. And then boom, skull and bones. We're in. Just like the TV shows. What is a common type of encoding used by websites? Base 64. Perfect. So now we're finding IDORs in hashed IDs. Hashed IDs are a little bit more complicated to deal with than encoded ones, but they may follow a predictable pattern, such as being the hash version of integer values. For example, the ID number 123 would become this if MD5 hashing were in use. It's worthwhile putting any discovered hashes through a website service like crackstation.net, which has a database of billions of hash to value results to see if we can find any matches. And this is a good tip for CTFs. It's not this website, but there's another website out there where you can um, get they have like common hashes or something like that. And you can have, like, say, for example, you have like the beginning part of a hash. You can find you'll be able to like find out like what hash is being used because you have like a certain part of the hash, or if there's like salt or something involved like that. What is a common algorithm used for hashing IDs? MD5. And MD5 is just message digest algorithm 5. It's like a cryptographic, it's like used to verify data integrity and check some values. So sometimes on certain websites, you might be downloading like um, something. I can't think of the word. It's like you're downloading like files or something, or a script, and it'll give you that hash value, and you're supposed to check to make sure that the hash is or that the data is exactly what it was when they posted it, that you have the same version. And of course, MD5 is stronger than other hashing algorithms out there. Unpredictable IDs. If the ID cannot be detected using the above methods, an excellent method of IDOR detection is to create two accounts and swap the ID numbers between them. If you can view the other user's content using their ID number while still being logged in with a different account, or not logged in at all, you have found a valid IDOR vulnerability. What is the minimum number of counts you need to create to check for IDORs between accounts? And that's going to be two. At minimum, you need two: your account and your burner account, for testing purposes, of course. We don't just go out and do these things in the wild, that is illegal. Where are they located? Where are IDORs located? The vulnerable endpoints you're targeting may not always be something you see in the address bar. It could be your content, it could be content your browser loads in via an AJAX request, or something you find referenced in a JavaScript file. Sometimes endpoints could have an unreferenced parameter that may have been of some use during development and got pushed into production. For example, you may notice a call to user slash details displaying your user information authenticated through your session. But through an attacker, but though an attacker known as parameter miming, but through an attack known as parameter mining, you discover a parameter called user underscore ID that can use that you can use to display other users' information. For example, user details user ID equals 123. So this was dev and this is prod. And that makes a lot of sense with regards to exactly what we're going with here. Okay. Should we have uh-oh. Press the start machine button. So we're starting the machine. Were we supposed to start the attack box? Uh I always forget. We go through this every time. Hold on. Okay, we're gonna let that get started. I I'm not sure. All right, we'll go through this. Firstly, you'll need to log in. To do this, click on the customers section and create an account. Once logged in, click on your account tab. Okay. So we're going to have to log in. So I think we need to wait. Does anyone have any questions while we wait for this to load up? Okay. The Your Account section gives you the ability to change your information, such as username, email address, and password. You'll notice the username and email address fields pre-filled in with your information. We'll start by investigating how this information gets pre-filled. If you open your browser developer tools, select the network tab, and then refresh the page, you'll see a call to an endpoint with the path API version 1 customer ID equals, and then we have our user ID here. Okay. Was I supposed to run this on my computer? We'll allow pasting. Oh, I don't think we needed the attack box. We'll see. We'll cross that bridge when we get to it. Okay. So we need to log in and create an account. Click the customers section and create an account. We'll go with username, cloud, login. It says sign up. Were we supposed to hit sign up? Oh, of course I have to hit sign up. Cloud, um, cloud at did I hit the caps lock? I did. Cloud at okay. What is going on? Why is it trying to save this? Okay. So now we're in. We'll start by investigating. Your account section gives you the ability to change information. So the your account tab. All right, perfect. And now we want to go and look at the network tab in our um, in our developer tools. We'll go to the network tab, and then they told us to refresh the page. And right here, we see the call to reference customer ID 15. Let me see if I can zoom in some. Oh, you can't. Oh, that's really unlucky. Maybe there's a zoom on this one. Okay. It's just gonna be tiny. Okay, perfect. So we see here, and is that the flag it wants us to get? We'll just this page returns in JSON format your user ID, username, and email address. Right there. We can see from the path that the user information shown is taken from the query strings ID parameter. So this is exactly where we are right here. We just went into our developer tools, the network tab refreshed so we could get some fresh information. And we clicked on it, went to the response, and we see here. So what is the username for user ID 1? Hold on. Did it tell us? You'll see an endpoint to this. And then we need to put that into user ID equals what's the full thing? Customer ID. Can I copy that? Open in a new tab. Customer ID 15 is me, that's Cloud. And customer ID equals 1. The username is Adam84. Should probably close this tab out. What is the user ID for number 1? Adam84. And what is the email address for user ID number 3? So we'll go here, we'll put in number 3. And the email address is j@fakemail.tryhackme. Yeah, fakemail.thm. What is the email? j@fakemail.tryhackme. Okay, perfect. So that's going to be the end of that room, IDOR. The next room is going to be file inclusion, and we'll probably do that one next week as well. Does anyone have any questions for me? I will upload this. This one will be an easy upload because there's no information I have to blur out. Um, and thank you all for coming. Thank you all for joining me tonight. Have a good night. Have a great rest of your day and night.